Good morning guys. Katong nga late og kuan, paki-ask na lang sa inyong classmate regarding sa attendance. Na i-copy and paste nila balik ang attendance para di na tama interrupt. Okay, so madunggan ba ko? Check mic 1 2 3. 1 2 3.
Yes, sir.
Maklaro ba
Yes,
akong
sir.
maklaro akong gi-share? Makita niya akong gi-share ha.
Yes, sir. Yes, sir.
Okay,
Yes,
so
sir.
kuan na siya no. So this will be our October 8, October 14 na kuan week. So, nata YouTube channel. So, nagdugang kog dagan-dagan ng mga video. Considering na dagan-dagan to lang topic. Okay? So, mag-share na ko sa ko ang entire screen kay dili ma-share ang PowerPoint. Sa window din sa window. Ang PowerPoint din makita kung PowerPoint. Ano pa? Hindi man. Entire screen. So, I'll be sharing my PowerPoint. Makita ba akong PowerPoint?
Yes,
Yes,
sir.
sir.
Okay, very good. So, napabay nagkuan, mag-admit. Sige na mag-admit. Ano ako ng study yan eh. Kuan eh, co-host. Di ko kabalon sa pag-co-host. Okay, so, topic for today is mechanical variables measurement, instruments, and sensors. So, we'll be dealing the fundamental mechanical laws, mass rate density, specific gravity, stress strain, pressure, level, flow, temperature, humidity, viscosity, pH, etc. Okay, so let's start with velocity. So velocity could be either linear or angular. So basically, velocity is just rate of change of distance. Pag ingon pagkag angular, so instead of linear distance, it is angular distance. So bali patuyok siya. That's why it's theta. No? Theta. That's the angular distance. Then omega is kuan, the angular velocity. Now, the same is true with linear acceleration and angular acceleration. So, acceleration is the rate of change of velocity. So, the unit will be meters per second square for metric system. Then, for angular velocity or acceleration, the other is radian per square seconds. Second square. Now, doon ako ipangutana. Kinsa may na motor sa inyo diri or sakyanan? Ba? Guys? Na naka-experience niyo drive og motor diri, motorcycle o madunggan pa ba ko? Check mark one
Yes, sir.
2.
Madunggan pa, sir.
Okay, so ito may naka-experience niyo drive diri.
Ako, sir. Motora, sir.
Okay, very good. Now let us say
Tama,
na
sir.
kay 110 na cc na engine sa motor, no? Let's say you're going to reach say the speed of 60 kilometers per hour or 60 kph. Dayon versus na if you're going to compare it with a 200 cc or even higher, no? 600 cc siguro na motor, then the objective is to reach the speed or velocity of 60 kph. Ang pangutana, what do you think is the difference between the two engines or two motorcycle in terms of experience? Tsaka guys, tagan-tagan lang good.
Ang torque niya, sir.
Okay. So, advance kayo mag-isip ba kay ang topic is acceleration velocity na ka sa torque. Okay. So, but then again, yes, true na mas difference ang ilang torque. What else?
Yung
Para sa tong torque.
acceleration, sir. Dili pareha, sir.
Very good. So, can you explain further nga nung dili pareha ilang
Mas
acceleration?
mas ang acceleration ng katong 200cc sir kaysa sa katong 110 sir.
Mhm. So, nakasabot mo to guys, ingon niya, mas fast daw ang acceleration ang 200cc compared to 110, no? Agree mo ato? So, inaniyo na to pag-explain, no? So, ang acceleration is value man siya. So, pwede ka makaingon na mas dakog value ang itong dako na engine na motorcycle. But in terms of experience, inani ang experience, no? Let us say, nag-start ka from 10 kph, no? 10 kilometers per hour, mapay pagpadagan nimo. Now, if you are using a 110cc na engine na motorcycle, perhaps the objective of reaching 60 kph, no, from starting from 10 kph, siguro it would took mga kuan siguro no 4 seconds, I don't know. Di man pud ko kabantay kay kung maabot na kuana na speed, siguro no 4 to 5 seconds. But if you're going to compare that with a 200cc or above, no, siguro mga relatively basig 2 seconds lang, no? So ang kaning acceleration magamit ni sa pag-overtake. I'm not suggesting na dapat kabalo mo mag-overtake, pero dapat you know when to overtake. Kung ang imong motor hinay, no? Hinay og acceleration, so check din mo kung kakaya baka maka reach sa certain na velocity, no? So that's the difference between velocity and acceleration, no? Ang acceleration is the rate of change of velocity. So kakusgon niya mag-change from small velocity to a higher velocity in terms of driving. Itong yun na example ng driving. So I hope na nasabta ninyo na ay nag-accept all. Okay, so let's continue. Now, we go now to Newton's second law. The first law it has something to do with the inertia. The second law is about the force, no? The force and the torque. So, mao na ning giingon niya na mas dako og torque, of course, ang higher na engine or bigger na engine. Okay? So, force is equal to mass times acceleration, while the torque is the moment of inertia times the angular acceleration. So, in simple terms, no, ang kaning torque, kuha na siya, twisted force or gipatuyok lang na force. Nga lang para dili ng lintang. However, kung sir, naara ba po may math? Yeah, calculus or even differential equation. So that's why na yung mga formula na represented in calculus format or differential equation. So, sa may pasabutan ng tornero, force is mass times the change of velocity. So, some change of velocity with respect to time, that is acceleration or the first derivative of velocity with respect to time. Kaning second order na or second degree of, differential or differential equation na kay d squared x or dt squared. So pasabutan na kung ano, the second derivative of the displacement. So ang x ni mo na mo ang displacement. Now the same is true po diri sa torque. Okay? So example, a mass of 30 kilograms is accelerated at a rate of 4 meters per second squared. Calculate the force used to do it. So simple na siya na kung ano, duwara ka. Given, then you just think of a formula that is suitable for the given. So, kadumdum ka ang kuan. Newton's second law. Very good, no? Force equals to mass times acceleration. The mass is 30 kilograms. Then the acceleration is 4 meters per second squared. Then, will give you 120 newton. So, kanilang newton ang ang unit din niya is kilogram meter divided by seconds squared. Now, another example is a flywheel. Flywheel. Pagpatuyo ko ni mo ni siya, sige lang nagtuyok, no, less ang yung friction. That's why more siya wheel na mo fly, or flywheel. A flywheel is accelerated at the rate of 4 radians per second square by a torque of 10 Newton meter. Calculate the moment of inertia. So just remember, just analyze the ano, given, then just remember the formula. So therefore, the formula, torque, moment of inertia times angular acceleration. So given ang torque, given po ang acceleration, then therefore the moment of inertia is just torque divided by angular acceleration. Okay, so that's why 10 Newton meter divided by 4 radians second square. So that will give you 2.5 kilogram uh, cubic meter. Okay? So kung ginsa na pagkuha, dapat bungkagon ni mo ning Newton. Okay? Para magkuha ni mo ning unit. Istorya naman ako gani ang unit. Okay? So another example is calculate the angular velocity of a flywheel that turns 120 radians in 3 seconds. So kaning 120 radians is angular distance or displacement. Okay? So simple ra, no? Just the unit of the formula of velocity. But in this case, it's angular velocity. Okay? So simple lang, no? Na kay distance divided by time. No, ma'am, ng velocity. So happen lang the unit is an angular velocity. So radians, 120 radians divided by 3 seconds. So that will give you 40 radians per second. Ano mo ang angular velocity. Okay, so kung wala mo yung pangutana, then let's proceed to mass, weight, density, and specific gravity. Okay, mass and weight, okay, are often used interchangeably. So sometimes ang mass may mong weight, ang weight may mong mass, no? So mga na ang usual na cases na there is kuan ka na ambiguity, no? So na sila kailangan. So mass is a quantitative measure of inertia of a body at rest, no? It's the product of density and volume. So if you remember sa inyong chemistry, density is called mass per unit volume. So kung solbo ni mo ang mass, ito is volume times density. Okay? However, pag may kag-weight, it's force. No? Dili ang mass, may ang force. It's the weight. No? So it's the force with which a body is attracted toward the earth. Okay? So therefore, weight is just mass multiplied by gravity. So ang pangutana, same ba ang weight nato diri sa earth compared sa moon? Guys,
Dili, sir.
idea. Okay,
Dili,
dili,
sir.
no? Kaysa ang moon man gamay man siya, no? Gamay. So relative man pud ang size sa kuan, no? Sa object na maka-generate siya og gravitational pull. So therefore, in moon mas gamay ang gravity. Pero constant ang atong mass. Constant atong mass. So therefore, our weight experience or the weight or the force of our weight, no, in the moon is different diri sa earth. So mas bugat ta diri sa earth. So kung gusto ka na feeling nimo na dili ka bugat kay kuha na kay katambok kay because of this pandemic siguro tagkaon na ni wala kay ta exercise. Kung gusto ka na gaan naman ako ang weight. O gaan lagi ka basta moadto ka sa moon. Okay? Moadto ka sa moon mas gaan. Okay, so let's continue. So, weighing scale or a mechanical weighing scale. So, mga example of a mechanical weighing scale. No? So, the equal arm balance was probably the first instrument used for weighing. So, ano siya? Taraan na kayo ba? There's also, siguro inyong chemistry, no? A subject. Naka-encounter mo this is a beam balance. No? Duwa lang yung counterbalance na in terms of grams siguro, and report in terms of 10 grams na calibration. Then, we have also a triple beam balance. Ang advantage sa triple beam, tulo ka buok iyahang counterweight no na siya grams sa tubangan, then followed by 100 grams na calibration, then followed by 10 grams. So, kung gusto ka na magdalit ka, pwede ra ning triple beam balance. Then pwede po ka magdugang og counterweight dire na siya pakapin. Same is true with the beam balance, pwede po ka magbutang og counterweight. Pag dili na kayahon sa mga default na counterweight dire sa ubos. Okay? And we have also a spring balance. So allow me to show you a video na naa sa to ang kuan, sa to ang channel, YouTube channel. Share a tab. Then, okay, so kita mo siguro niya to ang kuan ba? To ang step, no? October 8 to October 14, you click this YouTube channel. Okay, so kung naamoy time, no, you could always review kung ganahan mo magtanaw sa YouTube. Then particularly kaning Oxloop, no, and spring balance sa ato na i-play.
You created a business. Now, create videos for your business, easily and instant.
Spring balance. Objective: to understand the principle and working of a spring balance. A spring balance is
Madunggan
used for
naman ang
measuring
audio
the
ba?
weight of an object. It
Yes,
works on
sir.
the principle of
Yes, sir.
Hooke's
Yes, sir.
law, which says that the elongation of a spring is directly proportional to the load supported by the spring. Hooke's law can be stated as F is equal to minus K multiplied by X, where F is the load attached, K is the spring constant, and X is the elongation of the spring. The deformation of the spring and load attached are related linearly, meaning the elongation or stretching of the spring will double with the doubling of any weight hung from it. The spring balance consists of a steel spring. Its upper end is attached to a support, while the lower end has a hook attached so that objects can be suspended from it. The spring itself is typically enclosed inside a metal casing, and there will be some form of a pointer that can slide across a scale of measured increments indicating weight. The initial reading on the spring balance will be calibrated to 0 on the scale. When a load is attached to the hook, gravitational forces will pull the spring in a downwards direction. Conversely, the force of the spring will pull the load in the opposite direction. Once these two opposing forces, the forces of gravity and the spring, are balanced, the load will become stationary. The pointer will move along the scale, stopping at a reading which will give the weight of the load. The scale is usually marked in newtons and grams. Summary: the spring balance works on the principle of Hooke's law. The spring balance is used to measure the weight of a body that is attached to the hook of the spring.
Okay, so I hope na nasabtan ko ninyong simple discussion regarding spring balance, no, as used as a weighing scale. So kung makabantay siguro mo na mamaligya sa inyong isda sa inyong silingan, okay, you are bringing this spring balance as the weighing scale. Okay, so so we apply now the theory, no, the theory of spring balance, no, in the theoretical computation of a weight, no, of a particular object. Example, so madunggan naman ko, no? When a container is placed on a spring balance with an elongation constant or spring constant of 65 pounds per inch or 11.6 kilogram per centimeter, the spring is then stretched. No, ma-stretch siya to 3.2 inches or 8.1 centimeter. The question is, what is now the theoretical weight of the container? So, isa ni siya kabugaton. So, originally na siya diri sa reference line, but because of the weight, no, or the force, the weight of the object na displaced or there is displacement, no, from this reference line until this position. The question is, what is now the weight of the container? So applying Hooke's law, no, force times the x, no, which is the displacement. So therefore, it will give you a 208 pound. In terms of kilogram, that is 93.96 kilogram. So kung namoy spring, then you want to make a weighing scale, a mechanical weighing scale. So pwede nimo ina yung pag-test. No? Dapat na kay known na standard na weight, no? Dapat kato na known na standard na weight, accurate siya para ang imong spring balance accurate pod. Dayon different weights, no? Calibrate nimo from different points or different weights para pwede nimo computeon ang iyang spring constant, no? I-average nimo yung spring constant, then you have now your own weighing scale. Okay, mura ginani na idea, no? Dagan kay test samples there, no? For different weights, no? For different weights. Para ma-average din mo ang K1 yung ma-measure, K2, K3, K4. Okay, para makahimo ka og spring balance na mechanical weighing scale or timbangan in short. Okay? So that's it. So we go now to torque, no? So padung na pud ta sa gitawag nga beam balance, no? Ang timbangan dili ra man spring balance, no? Napoy combination of beam balance. Particularly kung kanang kuan kanang kinsa may gapamaligya diri naka-try experience na mamaligya og kanang kuan litsunon na baboy, no? Ang pinakamadali-dali ra gid na type na weighing scale is a beam balance. I don't know kung naka-experience mo, ako naka-experience mo ko nangita mig baboy pick up dito taas kaya marag espada na ko beam balance, pero actually it's a beam balance. Kasi counterweight. So before we do that, let's discuss first moment or force or torque rather. So torque na kay fulcrum. Dayon na kay force na generate, then to compute for a torque or the moment, no? So it's force times the perpendicular distance. Mora na siya. On the other hand, kung na kay couple, so pasabot duwa na sila. No? Force acting on this side, upper side, and there is a force acting on the lower side. Dayon na kay fulcrum at the center, no? So mutuyok na siya, no? Tuyok na siya. So therefore, the distance between the two forces, no? The same ragapon na couple is equal to force times distance. Okay, so we go now to katotong istorya, no? Kung kuan guys siya from scientific na kuan grade na instrument, then pwede mo nganlan as analytical beam balance. Pero kung ordinary lang, pwede rin nganlan as beam or lever balance. So, inanara siyang principle. You have fulcrum, no? Pareha tong sample na to na picture sa chemistry, beam balance or even triple beam balance. No? Same na sila na principle. No? Nasa sila beam. No? Then di balance. Mara gina, pareha po sa katong lingon na magtimbang ka baboy, no? Na nakasabukid niya Wala lang magdala-dala ka katong bugat kayo na kuan na weighing scale. Ang pinakadali ra gyud mo dala-dalahon, especially kung magmotor pud ka, makaning kuan, no? Beam balance. So, simple lang na kay fulcrum. Then one of the kuan side is your kuan siguro object or ang baboy. Then on the other side is the counterbalance. So, ang counterbalance ang imong gina-move, slide mo siya para ma-determine mo yung weight. But in this case, natin gitawag na equilibrium formula, no? Applying the force and the torque or the moment, no? So ang moment or torque on the left side is actually from the fulcrum, no? Weight 1 times length. So mao na to ang torque or moment, no, sa left side. On the right side, the equilibrium ni dapat mag-equilibrium siya or else dili na sila equal. Okay? So the weight 2 multiplied by the distance from the fulcrum, which is r. So that's it, no? This is the basic, pinaka-basic ni na instrument ba, no? Yung nila na you need to know kung ano, life skills na mga such as knowing the basic principle of the beam balance, na especially kung nakas bukid ng ita o litsunon. Okay? Ang pinakadali ra gyud dalo na kuan is a beam balance type na weighing scale. Okay, so we have now this worded problem. Right? Sometimes pag estudyante ta, no, or still studying, you should master the the worded problems. Kaya di na to makita tong analytical na thinking skills. So 2 pounds of potatoes, na 2 pounds of potatoes are being weighed, no, with a balance. So pwede po ni siya baboy kuno ay no, lecture ko na baboy with a balance or with a beam balance. So the counterweight on the other side of the balance is 0.5 pounds. If the balance arm from the potatoes to the fulcrum is 6 inches long, no? So ang moment arm sa imong potatoes is 6 inches long. How far from the fulcrum must be the counterbalance be placed? So kaning imong counterweight na balance unsa the distance ani sa from the fulcrum. So nakalimot ko drawing, but anyway, duara man ni the left side of the equilibrium of the beam balance and the right side of the equilibrium of the beam balance. So duara man na sa ka-factor, the weight and the distance. Diri pod, the weight and the distance. So ang unknown din na distance is ang kaning counterweight balance. So mo ning unknown. Kini sa pikas na equilibrium, no? Known man tanan, including the weight sa imong potatoes and the distance from the fulcrum, which is 6 inches long or 0.5 feet. Na depende lang, no? Kung i-inches nimo ni pwede gyapon, kung i-feet nimo pwede gyapon. But in this case, let us use feet, no? So therefore, solving for the unknown, simply divide 0.5 diri sa on this side of the equation. So actually, ang answer is 2. Kaya makancel man yung 0.5 at 0.5. So therefore, the counterweight, no, balance is actually located 2 feet from the right, no. So mas layo din yung imuhang counterweight. Kaya naman, mas gaan ba siya? So palayo-layuan na nimo sa imong beam balance. However, kaning 2 pound kay na potatoes, bugat man siya, man ang mas duol-duol sa imong fulcrum of the beam balance. Okay, so murag na yung nag-appeal na po. Okay, so let's continue. Na may pangutana? Kakita na ba mo og kuan? Beam balance na kuan? Weighing scale na especially kuan lang gina bit-bit lang nimo, no? Gaan na siya, di pareha nang magtimbang dito dagko anay ng mga baboy sa merkado, mga dagko na timbangan. Kato is panglitsunon man so pwede ra. Gagmay ra mga litsunon. Gawas so anay ang litsun dili makaya sa kuan. Katong counterweight unless kung ready ka sa imong counterweight sa imong beam balance. Okay? So let's continue. So this is actually a load cell. Karaan na ganito siya na load cell. Now this is not kanang required na assignment. Pang practice ninyo ni, no? Try to solve this one, practice solving. Dili na ta mag-assignment, no? Quiz na na to diretso. Pareha naman ang assignment ug mag-quiz. Ang disadvantage sa assignment kay you need to write your answer. Dere is kung sa step na tayo butang quiz diretso, answer diretso. Balag na kay solution sa imong kuan, papel, no? So you practice this one set of problems. Okay? Para ma-master nimo ang topic regarding beam balance and weight force. Okay? Okay, so we go now to, kung mana naman taning mass and weight, no? We go now to density. So, sabihin ko pa, no? Density is the mass per unit volume. So, mana yung formula. Okay, for English unit that is seldom used is kaning slug, no? Pound slug. Pound slug. Kailangan po yung pound force. Okay? So, mana lang unit sa English. However, in metric system and in SI unit, masayon na siya, dili siya kalibog. Now, nganong mag-study pa mo tag other na units other than metric system? Ginagamit man nato sa kuano. We are influenced by Western culture. So, ang ila pong trading, so ang mga screw na gipanggamit, napoy mga inches, no? Napoy millimeter. So, di mo na siya pwede ma-interchange. Try ra gud palit og millimeter na screw. No? Pulihan to nimong inches na screw. Maguba gyud na imong groove. Okay? So, that's the reason na dapat makabalo ta sa basic difference. There is difference in terms of unit. Though there is equivalence. Pwede nimo ma-convert. Bigyan na siya. Lisa may yung 50 mm, no? Sanitary pipe. Kung inches na nimo, no? Inches na nimo, na wala, di ka kita 50 mm. Ang pinakaduol ana 2 inches, no? In terms of English na unit. Pero pag mm siya, dili. So, mana siya, no? Though there is a slight difference, pero di na maigo, no? Nanay gamay na difference in terms of wielding sa imong pipe. No? Na siya difference in terms of the diameter inside the pipe. Okay, so let's proceed, no? Specific weight, no? Or in Greek letter gamma, defined as the weight per unit volume. So, tanaw na to diri. Sir, kanang specific weight. Paano din na? Ay, mura rin na density. Yes. Density ra na siya multiplied by the gravitational acceleration. Ano man? May weight in terms, instead na mass siya. Okay? Instead na mass, weight ang ibutang. Kung weight na siya, dili na siya density. Ang tawag na is specific weight. Now, we have also another mechanical variable or physical quantity, which is the specific gravity or SG. So, specific gravity is actually reference, no, with respect to the density of the water. So, it's just a ratio, no? Density of the material divided by the density of the water. So, ang pangutana, sir, what is the specific gravity of the water? So, density of the water divided by the density of the water, ang specific gravity niya, 1. Okay? Pasabot, ang reference mo kay density of the water man. Yung water ato ang baseline. So, that is what is meant by specific gravity. So, we have these different materials. Ang pinakagaan diri is a gasoline crude oil, no? Dili dahil napagi ammonia. But anyway, kanilang gasoline oil kay napo experience ani, no? Pag isagol na nimo ang gasoline oil sa tubig, what will happen? So mulutaw siya. So since mulutaw man, no, during fire, especially kung masunog ang gatong gasoline engine on top of the water, dili nimo buhusan og tubig. The more nimo buhusan ng tubig, musaka ang gasoline. So that's why you need a fire extinguisher, chemical based na extinguishing, or dili tubig yung gamitin other than tubig. Okay? So, mano siya. So, manotice po nimo ang water is one lagi yung specific gravity kay it is referenced by itself man. Okay? So, ang acetone day mas gaan. So, by seeing the specific gravity, makaingon din ka mas gaan ang acetone, gaan ang ammonia, mas gaan ang benzene, mas gaan ang gasoline. Pero mas bugat ang mercury as well as the glycerin. Okay? We have this density and we have this specific weight. So, naara sa inyo, kung memorize na ninyo, no? Okay, so we go now to the standard temperature pressure. Okay, in the USA system of units, no, imperial, no, and USA system of units, ang temperature dapat sa air, no, the standard temperature is 60 degrees Fahrenheit. Then the standard pressure must be 1 atmospheric pressure, okay, and equivalent. Then you could say na pwede naman yung magamit ng mga values, no? Let's say the gravitational acceleration. So, pwede naman siya gamitin at the STP na condition. So, example, no? Atong practice, ito ang ano, skill and solving worded problems and dealing with different formulas. What is the density of a material whose specific weight is 27 kilonewton per cubic meter? So take note, specific weight. So parehara na sa density. That's why what is parehara na sa density except na naa siya gravitational acceleration. That's why the formula now is specific weight, no? Density multiplied by the gravitational acceleration. Mara na ilang difference na sa gravitational acceleration. So therefore, divide na nimo given man ang specific weight, diyan known man pud ang gravitational acceleration at STP, standard temperature pressure. So, mga ang assumption. Then, you could solve for the density, which is 2.75, no? Times 10 to the 3 or 1,000. 2.75 times 1,000 kilogram per cubic meter. Okay, so we go now to density measuring devices. Another instrument or device or sensor na naka-measure of density. And this is what is known as hydrometer. Hydrometer are the simplest device for measuring specific weight or density of a liquid. The device consists of a graduated glass tube with a weight at one end, which causes the device to float in an upright position. So, na yung mga different na mga variations niya. Okay? So, atong tanawon ang tanawon na to ang video niya. So, ako nang stop sharing. Okay, so we're going to watch for the video.
The density of a liquid can be determined by using a device called a hydrometer. This is a weighted tube of mass m, one end of which is partially submerged in a liquid. The force of gravity and the buoyant force affecting the tube are in balance. There is a volume scale on the side of the tube on which we can read the volume of the tube that is submerged below the surface of the liquid. Since the forces Fg and Fb are in equilibrium, we can determine the density of the liquid. Often, a hydrometer will have two scales, one indicating the volume of a liquid and one indicating its density.
If you wear glasses or
The density of a liquid can be determined by using a device. The density of a liquid can be determined by using
Okay, so this is the application of hydrometer in lead acid battery. Guys, kita na experience niyo about lead acid battery? Asa man na makita ng lead acid battery? Hello? Madunggan pa ba ko?
Yes, sir, madam.
Yes, sir. Yes, sir.
Okay, so kading lead acid battery, man yung mga battery that are commonly, no, common lang, dili all, commonly used in car batteries, in car, in motorcycle. Pero kung gusto ka na nakay budget, no, pwede po ka magpuli of gel na type. No? Pero kaning kaning lead acid na battery, man yung the cheapest solution. Now, when I was still working in an industrial plant, one of the requirement is kaning electric forklift. Kadungog na mag-electric forklift or forklift pa inyo nadunggan.
Forklift na, sir.
Okay, so napo electric na forklift na most of the forklift na outside mill ganang sa gawas gawas sa plant mismo. Pwede rin na sila mga no? Engine based or dili engine based kaning makaingon ka na fuel gasoline ang fuel nila no based na forklift. Pero katong sa inside mill bawal man ang particularly if the warehouse is warehousing a food product no in a food manufacturing plant, bawal ang ganang mga gasolina, mga crude oils kay manimaho man sila. Agree, disagree?
Agree, sir.
Agree, sir.
Agree.
Okay, so that's why inside a food warehouse, dapat ang ginagamit na electric forklift. Okay, kay wala man ibaho. Di na siya ga-emit og Di na siya ga-emit. Minimal hasta ang mga nila ang mga lubricants is food grade no ginagamit kay para if ever there will be spillage or kanang tulo-tulo dili siya maka-contaminate sa imong food product. Okay? So this is the reason no. So nagamit mga lead acid na battery kay pinaka-cheapest man siya. Then one of the preventive maintenance is to check from time to time, especially kung di na mugana, hapit na di mugana ang electric forklift. So gina-check ang iyahang ang iyahang density sa acid, no? Kabalo mo nga no ginganlan sa lead acid. So kung tanaw na nimo sa picture, nanana siya unom ka buslot, no? Diya gipangbutang ang gitawag na sulfuric acid or battery solution, no? So there are 6 cells, no? Naka-series na ang 6 cells. So roughly mga 2 kapin, no? 2 volts. 2 times 6 pila man na 12, no? Or buta na to 2.2, no? Or even 2.3 ampere voltage na cell, no? Or 2.25 siguro per cell. Dahil sa isa ka cell, nanay mga plates. So, ang kaning siguro, kaning sa car, 7 plates siguro, no? 7 plates, may 9. Di na ko memorize, pero inana siya, no? Ang type of plates na ginamit is a lead, no? That's why ginganlan siya lead acid. Now, ang part sa maintenance aning sa electric forklift, gina-check na mo ang battery solution. Pag-check gani, tanawan nimo, no? Gamitan nimo flashlight. Mag-check nimo kung ubos-ubos na gani ang battery solution, duwa imong option. Kung gamay ra ang difference, no? Pwede ka magdugag distilled water kung gamay lang. Pero kung dako ang difference, then you use battery solution. Barato naman ang battery solution, mga tag-40 ang litro man siguro sa una o karon ora pare-para iba. Mas cheaper gid siya, no? So going to maintain a lead acid battery, cheaper gid siya. Gadugang na kag lead acid gadugang kag battery solution or distilled water. Okay? So in terms of application sa hydrometer, so manotice niyo kanina picture is ang iyahang evaluation is nasa sa ang iyahang ang kaniyang indicator, nag-indicate siya sa white na naka-level siya sa white. So that is an indication na good siya, good. So acidic pangimuhang battery solution kaya na-charge siya, becomes more acidic. However, kung inani ang range sa imong battery solution, no, halos na ang imong float, no, ang float nimo mo kuan na siya, mulugdang, then ana siya sa red, then it requires kuan na siya, no, charging. So asa ito yung table lang, yung table dire. No, dapat na si table. Makita niyo yung table, guys. Pag ang specific gravity, no, niya is 1.1, then try to take slow charging, mga 2 amperes lang siguro, or mga 2 amperes at 4 to 12 hours, no, para makarecover ang imuhang battery. Pag naapog ka sa 1.15 to 1.2 ang imuhang specific gravity, then you need to charge this for 2 to 6 hours. Pero pag nakakadiri sa tunga-tunga, then it's good, no, 1.25. So it's good. No? Ang iyang battery voltage sana mga 12.8, no, or even 12.7. So that's a good na kuan na lead acid na battery. Good ang iyang kuan battery. Pero pag mulapas pagka diri, acidic na siya. No? Sobraan na siya ka acidic. So pag sobraan ka acidic, guys, buhaton niyo na is dugang kag distilled water, no? As long na dili siya mulapas. So, pwede nimo kuhaan gamay ang acid. Okay? Dayon magdugang ka og distilled water para dili kay siya acidic. Okay? So, mao man ang iyong nabalaan sa chemistry, no? Kung acidic kay siya, bibilagan og tubig para ma-neutralize. Okay? So, naamay pangutana. So, kung wala may pangutana, by the way, guys, in my experience, there will be power outage, no? Kung di, ang kanang 5 ampere hour na kuan na lead acid na battery sa motor, pwede na nimo kuan na man siya alternator or generator na gamay, no? So, pwede ka palit og ganang gamay ra gyapon pod na kuan na inverter. During power outage, kinahanglan gyud mo na magka generate kag alternating current of 220 volts. Ato ang gibuhat, no? Pansak na ko ang inverter sa kuan, positive and negative sa ko ang lead acid na battery, no? So ma-invert siya nya, dali ra na malubat kay 4 ampere hour lagi, 5 ampere hour ang iyang capacity. So ang gibuhat nako is padagan ako ang engine, proto kuan na nako ang iyang minor, ako lang pakusgan gamay para mura siya kuan na kay gitawag na mini na generator, naga-charge sa imong battery, at the same time di-invert siya para ma-convert to 220 volts. So survive ko by mga 5 hours, no? Ulay kuan dahil malubat man na siya kay tungod sa kuan, no? Ang load nako TV man load ko, wala pa ko nagtan-og TV, mas taas siguro ang kuan ang time na may experience. Okay, so that was my experience. Kung naamoy na experience po, pwede pa na niya gamitin. Okay, so stop sharing. Balik ka sa tuang PowerPoint. Kaya sa itong PowerPoint. Okay, so na may pangutana, makitaan pa rin akong hydrometer. Okay, so that is an hydrometer. Kung wala may pangutana, we go now to stress strain. So, when a force acts directly in an area, the result is a direct stress, no? Same rin na sa tao ba, you know? Dagan kay trabaho, exert so much force. So, magka-stress ka. So, same is true. So, the formula is kanina, sigma is equals force per unit area. Kung stretch siya na force, then, kung full, kung birawon mo, then, it is, stretch, then it is tensile force. May positive stress. Dili positive ang stress, kaya positive lang yung direction. Dahil yung pushes or compressive siya, compressive pag i-compress mo siya. Okay? Now, what's the difference now in terms of stress and strain? Pero ang kadiklayan ng stress and strain, simple na guys. If you keep on stressing, no, yourself as well as the object, magka-strain na siya. Ano siya? Strain is the result of stress. Now, if you keep on pulling this object, no, ano cylindrical round bar na object, sige na magbirahon. So, there will be a point na mainat siya, no? Mainat. Pag inat niya, then there will be a change in length. And therefore, there is now direct strain produced. So, makaproduce siya strain. So, mainat na. If there will be elongation, no, or compression, na magamay ang length, then there is direct strain. So, mara na kailangan sa stress and strain. Pag too much stress, magka-strain na siya. It's either giinat nimo or gi-compress. And this is the formula for the strain. Epsilon. Change of length divided by the length. And it has no units. Puro raman sila. Same length. Okay, so normally, pag gagmay lang ang strain, so microstrain. 7 times 10 to the negative 6 is 7 microstrain. So it can be either tensile strain or compressive strain. Then, we have now this additional na formula which is known as the modulus of elasticity. So ratio na siya. It's the ratio of the stress and strain. Since ang strain wala unit, so same ang unit sa modulus of elasticity sa imong stress. Okay, so it's a ratio na. Uy, naduble lagi. Okay, so we go now to elastic limit. So, let us say this is a steel. Pwede pa naman siya ma-stretch. No? Applyan ni mag-tensile force. Pag mo-reach na siya sa iyang elastic limit, dili na siya mubalik. No? Hindi siya mubalik. It's permanently stretched. Or to the point na ma-break pa siya, maputol. Okay? So, may pasabot sa elastic limit. Pag mulapas na ka ng limit, para yan ang kamot, birahon mo, no? Ipatry mo, ibirahin mong kamot. Pagbiraan na, di na gana siya mabalik. So, ano siya, na-reach na niyang elastic limit. Unlike ni elastic man, taas siya sa elastic limit. Okay? However, we cannot apply the ratio of the modulus of elasticity na stress divided by strain. Dili na nimo ma-apply kung na-reach na nimo ang elastic limit. So, usually, a strain gauge has a elastic limit, has a strain, no? Oh yeah, elastic limit of 300 micro strain. Same lang this lag unit. 3,000 rather, 3,000. For example, a metal round bar, which is part of the frame, is 50 millimeters diameter and 300 millimeter long. It has a tensile force. So, ibira siya kay tensile man. Acting on it, no, of 40 kilonewton. It tends to stretch. So, mabiragad. Given din ang iyang modulus of elasticity, which is 205 gigapascal, no? Pascal na siya basta stress or pressure. Ano yung unit or the SI unit. Calculate now the stress and the strain in the bar as well as the amount it stretches. So the formula for stress is force per unit area. So the first nimong sulbon is the area, which is the area of a circle because a round bar has a cross-sectional area of a circle. So, dapat kabalo mo solve sa area of a circle. Then, you can now calculate the stress. It's force per unit area. Okay, so ang force is 40 kilonewton man divided by this area. So, you have this one, Pascal. So, wala lang ako i-multiply ka para pwede ra ma-cancel. Then, you have this equal din siya. Kanina value, no, is also equal to 20.37 megapascal. Then take note that the modulus of elasticity is given, no, 205 gigapascal, and you have this modulus of elasticity na formula. Okay? Take note na solve na po ni mo yung stress. Solve na ang stress. solve na given ang modulus of elasticity, then pwede na nimo solve na ang strain. Mamo na sunod na pangutana, stress and strain. So therefore, the strain now is 96.89 microstrain or times 10 to the negative 6. Wala man sa unit. So manang butangan lang siya epsilon para to indicate that it's strain. Since no naman po niya yung strain, pwede mo makuha ang iyang delta L or mana iyang the amount it stretches. Ano na yung formula. Strain is delta L, the change of length, divided by the original length. So therefore, the change of length is equal to strain rather, times the original length. Then the strain is mamani. Wala na lang ako di sulat dia. Actually, mga siya. Then multiplied by 300 nm, which is the original length. Sa imong round bar, then you'll get the 0.029 millimeter stretch. So, nagka-strain gid siya kaya na may stretch. Mura na gikan sa gikan sa mga anak ka, kung babae ka. Ang modulus of elasticity sa imong tiyan, magka-stretch mark din ka. Okay? Na may pangutana or madunggan pa ba ko? Okay? So we go now to strain gauge. So, ano yung strain gauge? So actually, this is the reason stress strain to, Strain gauges are used in many instruments, to produce a digital weighing scale. Mana siya ang objective, Mana siya. Strain gauge is an element which is a very thin wire that is formed into a certain shape. Mana siya. Okay? So, allow me to share a video. Naga pa tayo video, para mas sabtan. So, extend lang tagamay. Lapas kita itong 1 hour na limit. Anyway. Uy, napagin join? Join. Share tao. Tab.
The density of a liquid can be determined by using a device called a hydrometer. This is a weighted tube of
For the past year, I've been working in secret on an improved version of my electric longboard. And so far, I implemented a new power switch, a new remote and a new control circuit that can not only receive information from the remote wirelessly, but also integrates a weight measuring system. This way, if you ever lose control of the electric longboard and must jump off, it recognizes that and brakes automatically. The key component that makes this weight measuring system possible is a so-called strain gauge, which is attached to my longboard underneath a protective layer of silicon. Such strain gauges are actually pretty common when it comes to measuring masses or forces electrically. So in this video, let's have a closer look at them and find out how we can integrate them in a circuit in order to measure a weight/force easily with a microcontroller. Let's get started. On closer inspection, is a strain gauge just a flexible piece of plastic on which a zigzag pattern of resistance wire is secured. By soldering two thin wires to its contacts and measuring the resistance of this particular strain gauge, then we get a value of around 120.4 ohms, which correlates with its datasheet. Besides the 120 ohm value, there also exists 350, 700 or 1000 ohms as standard values. And while my example strain gauge is kind of big, there also exist smaller variations, even sometimes with different patterns. But enough about the outer appearance. Let's rather find out how a piece of plastic can measure weight. And the answer is actually quite simple. By stretching or compressing the strain gauge, the resistance of its wire pattern increases or decreases slightly. That means the strain of the strain gauge is proportional to its resistance, which logically means we can calculate the mass of an object. So all we have to do is to properly glue the strain gauge to the object we want to apply force to and measure its resistance. Right? Well, it's not that simple, since non-extreme weights, aka more realistic forces, only create a very small, almost not measurable change in the resistance. What we have to utilize instead to fix this problem is a so-called Wheatstone bridge. By replacing R1 with the strain gauge and the rest of the resistors with precise 120 ohm resistors, and applying a 5V supply voltage to the circuits, we would get a voltage difference of 0 volts between the resistors if no force is applied, and a voltage proportional to the strain if a force is applied. That means we successfully converted the change in resistance into a voltage that we could now amplify with a differential op-amp configuration with a gain of, for example, 196, and then measure it with the analog to digital converter of a microcontroller. But there's still a noticeable problem which comes to mind when we have a look at the datasheet. It seems like the resistance of our strain gauge is temperature sensitive, which can easily mess up the measured voltage difference of the Wheatstone bridge. That is why you usually avoid such a quarter bridge with only one strain gauge, and instead utilize a half bridge with 2 strain gauges or a full bridge with 4 strain gauges. I always like to use the half bridge, since both strain gauge resistances are influenced by the temperature, and this mistake then gets subtracted by the nature of the Wheatstone bridge. Of course, you could also use 4 strain gauges to compensate for all kinds of undesired forces, but let's rather stick to the basics for now. Now, to easily adjust the resistance values of R3 and R4 corresponding to the strain gauge values, it is recommended to utilize 10-turn trimmers, so that after building up the circuits and connecting the strain gauges, you can adjust them until the output of your microcontroller's ADC spits out a voltage in between the supply voltage and ground. Now, by applying force to the object, we can see that the ADC's measured values change accordingly, which means we can use those values to measure weight. But since building up a proper strain gauge setup can be quite daunting and time consuming, there's also a cheap and easy alternative, known as a load cell. Those are basically aluminum profiles with 4 M4 holes for mounting, to which a complete Wheatstone bridge is already attached. All we have to do is to connect the red wire to 5 volts, the black wire to ground, and measure the voltage between the white and green wire. Like before, it is the voltage difference of the Wheatstone bridge that once again correlates with the force that we apply to the load cell. That means we could simply attach the load cell to 2 pieces of wood with M4 spacers and screws, build up the same amplifier circuit as before, feed it into an Arduino, and use the setup as a crude scale. But another, even simpler solution is to remove the op-amp circuits and instead utilize this HX711 breakout board. The HX711 IC is a 24-bit ADC with an integrated amplifier that features a maximum gain of 128. By soldering 4 wires to its right connector pads and thus connecting its data pin to pin 7, its clock pin to pin 8 and its power pins to 5 volts and ground of an Arduino, and connecting its E+, E-, A- and A+ pads to the load cell wires like I showed right here, and utilizing the HX711 Arduino library from SparkFun, we can output the scale readings through the serial monitor, which now reacts even to the tiniest changes in weight. The reason is that the 10-bit ADC of the Atmega 3208P microcontroller features a resolution of 1024 steps, which equals voltage steps of 4.9 millivolts. But now we got a 24-bit resolution, which equals a total of, believe it or not, 60,777,216 steps, which subsequential equals voltage steps of 0.298 microvolts. This way we might get more noise in the readings, but we can measure way smaller forces. And with that being said, you should now be familiar with the basics of strain gauge/load cells and how to use them to measure weight easily. I hope you enjoyed watching this video. If so, don't forget to like, share.
Okay, so I hope na sabdan ninyo ang no, how a strain gauge to a load cell to a digital weighing scale. Okay, so na may pangutana. Stop sharing. Share again my entire screen. Okay, so check my 1, 2, 3. So, mo na ang no? Mo na ang strain gauge. This being, mo na yung mga no? Example of a typical strain gauge. Okay, there are different types, no? Non-conductive polymers, piezoresistive, okay, and so on and so forth. Okay, kato na video ganiya, man siya. No, ano yang strain gauge. Pero kung magmanumana ra kagimo sa imong digital weighing scale using a strain gauge, no, it's a little bit complicated. However, we're going to buy an existing beam, no, beam type. Dili siya beam balance, beam type na load cell, and with the amplifier, no, na module. So pwede na. Pwede na naman siya gamitin sa Arduino. Okay? Pwede na naman siya gamitin sa So we go now to the mathematical aspect, no, or the theoretical side. So kabalo naman tayo ng mechanical strain, no? We introduce now the electrical strain, meaning delta R over R. So manotice to nimo pag idot-duot mo ang if you're going to apply stress, no, sa itong strain gauge, notice nimo that there will be changes in the resistance. Particular example niya 120 ohms. So that's why there is now an electrical strain, delta R over R. Then the ratio of the two, electrical and mechanical strain, becomes the gauge factor. Okay? Example, a strain gauge is glued to a structure. So pareha ito yung gibuhat, i-glue niya sa kaning plywood. It has a gauge factor of 2.1. Dili lang siya problem solving. Kung siya application. So kanya ito problem solving. Worded problem solving. It's a gauge factor of 2.1 and a resistance of 120.2 ohms. The structure is stressed. No? The appliance of force or stress. And the resistance changes to 120.25. Calculate now the strain and convert it into stress, where the elastic constant, no, modulus of elasticity is equal to 205 gigapascal. So, ang una nimong mag-compute ani isang delta R. So, kabalo mo nga na ang 120.2 na imo siyang 120.35. So, nana kay delta R. Then, of course, masolve nimo ang delta R over R, no? Or what is known as the electrical strain. No? So, nana kay value ana. Then, since given man ang imuhang modulus of elasticity, no? So, then the gauge factor is also given. So, mao na yung formula, no? The gauge factor is the ratio between electrical and mechanical strain. So, since solve naman nimo ang electrical strain, so masolve na po nimo ang strain niya. So, mao na siya. This is not the strain. rather solve further the stress. You have now the formula, na formula, no, na modulus of elasticity na ratio. So, given man ang E, 205 gigapascal, na-solve na po ng strain. So, therefore, the stress is 40.61 megapascal. So, kuha na siya. Analytical ta from time to time. No? Analyze din ta. Dili lang ta puro application. Kung puro application, di na ito madumduman. Ipares din ang theory and practice para na siya strong na recollection and learning. Okay, so mani ganiya ang circuit. So, nabantayan niyo. Actually, this is a Wheatstone bridge. Ito yung drawing. In this case, isa lang ang nabutang diri. But actually, pwede upat ang imong strain gauge. O pwede ra po daw duwa. Okay? So, this is a Wheatstone bridge. Then, modeling katong imong amplifier. No? Amplifier na module. Okay, so, ang kuha ni is to balance, no? Dapat zero ang output ni mo dire kung wala pa stress or load sa imong digital weighing scale na gihimo. So kung balance imong Wheatstone bridge according sa inyong circuit theory or circuit na laboratory, dapat naka-experience mo ang gitawag na Wheatstone bridge. Pag equal ang resistance, the voltage difference between the node, na kanina node at kaning dire ubos na node is zero. Ano siya? In figure, no current will flow through the galvanometer or voltmeter. No? If the four resistances satisfy an equilibrium na condition. Okay? So, what is this? So, gidungagan siya gitawag na amplifier. So, kita mo ato ang 18 na dual inline na package na IC giniya sa yang breadboard. Ano siya, no? An instrumentation amplifier or differential amplifier. Sa pangutana, kinsa na may nakakitaan ning op-amp. Nakakita na ning op-amp sa inyong electronics sa klase? Guys, napa mo diha. Check mic 1, 2, 3.
Yes, sir.
Yes, sir.
Okay, very good. Nakakita naman ning op-amp? Sa asa niyo na subject ni nakita ning op-amp? Yung triangle.
Electronics, sir.
So, very good kung nakaabot may op-amp. Pero ang pangutana, naka-arrange ba mo ginani na configuration? This is what is known as instrumentation amplifier. No? So, pwede nimo na siya i-derive ang iyang voltage gain. No? Ano yung voltage gain na equation. No? Pag i-divide din mo ng B out divided by Bn minus B2, ano yung voltage gain. Okay? So, hopefully, na-appreciate niyo yung electronics na magamit nato dito sa instrumentation. Na especially kung maghimo mo sensor, no? Sensor development. Pag sensor development mo, naagining duwa. Aside sa sensor, aside sa sensor. Na may sensor, na may Wheatstone bridge, na mo aning gitawag na instrumentation amplifier. Okay? Now, this is a Wheatstone bridge, no? Dayon, there is an additional potentiometer para in case the R1, R2, R3, R4 ni mo na resistor is balance, imbalance siya. So, para mas mabalance nyo siya. So, using this potentiometer. So, therefore, theoretically, if you're going to compute for the voltage across R1 or R2, R3, R4, they are equal. B1 is equal to B2, equal to B3, is equal to B4. Okay? Kaya naman, equal naman ang ilang resistances. Dayon, since equal naman, so katunga ra ang voltage diri sa taas at sa ubos. So therefore, ang B1 is actually Bs over 2. So nana ra na siya ang okay? So we continue. So ang solbo nato is B out, no? B out is B2 over B1. Okay, so higher potential minus lower potential. Wherein B2, no, ganiya is Bs over 2, no? Kung balance yan na condition. Minus kaning B1. So ang B1 po, pwede mo solbon using voltage division, no? By applying voltage division, R man sila equal na lagi. Dayon, duwara ka R ang imuhang ma-analyze, no? 2R. Then that's the time that you introduce this delta R, no? Or ang kaning strain gauge nimo na change in resistance. So you simplify the equation, the output, no? Mao na siya. Then you multiply by the factor. So ma-simplify na siya. So therefore, B output na so as the BS ani na. Dayon applying the gauge factor or the electrical strain, the ratio of mechanical strain. So pwede na yun siya ma-improve ang equation. So pwede na din yung memorization kanina na yung memorization. Okay? So example, kay worded problem, no? So 4 strain gauges are formed into a bridge with one only active na strain gauge. So the nominal resistance of all of them is 120. The gauge factor is 2.1 and the supply voltage is 10. Katong sa Arduino na example, 5 volts ko yung supply. Kani it's just for the sake of worded problem lang. Calculate the strain when the output from the bridge is 20 millivolts. So, ang sayo na ni mo buhaton, of course, the formula. Memorize the formula. Kung di ka ganahan mag-memorize, you derive the formula. Then, you simply substitute in say given. Then, finally, na-solve ni mo yung strain. Okay, so, nanara sa kasimple. Okay, so, we continue now on the application of digital weighing scale. No? So, ako na pong i-share ang tab. Guys, nganong agoy. Nakasabot mo ani actually the video is all about using the tear function. Yung tear. Sabot mo si tear. So kaning naa diri sa basta mabasa na nimo ang any digital weighing scale. Ngano importante man ang tear na function kasi maka-explain. Wala ganahan explain ako na lang. So, pasabot sa tear function is using tear function to zero a platter. Let's say, before ka magtimbang, nakay sudlanan, nakay basket. So, pag patong nimo sa basket, manotice mo ganiya sa video, nasa weight. No? Ay weight ang basket. Assuming kaning platter, na pinay-weight atong pangitaan sa pinapart na ditong-tong na. Kana. Okay, so, pagtungtong niya sa platter, or assuming nakay basket, nasa weight, di ba? Pila yung weight, guys? So, na kayo mabasa na 220. So, actually, kung ako may magbasa, it's 0.22 grams, no? Or kilograms rather. Karon, dili man nato apilon og timbang ang kaning platter or basket. So, ang buhaton nimo, pislito nimo ang tear. So, pislito niya tanawon. Okay. So, ang matimbang rin niya, ang saging lang. Okay? So, another function is ang zero, no? So, tanawa, yun sa na pagtislit ang zero. Okay, so manotice ninyo, ang timbangan now, nakatimbang sa negative. So, pwede ba rin mag-negative ang timbangan? No? Actually, pwede. Basta, kuha naman, no? Tensile mo ang kuha ng strain gauge. But anyway, so nag-negative siya kay naman kay flatter na weight. So mao tong pasabot sa tear function of 0. So karon ang buhaton niya, isliton niya ang 0. No, pag islit ng 0, mabalik na sa 0. Okay, so namay pangutana. So inana ra ka simple ang magamit dahil og weighing scale. Okay, so hapit na tamaw man. Ang next na to na consideration is digital weighing scale calibration. Dapat kabalo ta what is digital weighing scale calibration.
What are the benefits of a calibration? Do you know how accurately you are weighing? Do you know that every weighing result has a measurement uncertainty? Do you know this influences your product quality and the reproducibility of your results? Therefore, having a direct impact on your customer satisfaction? A comprehensive calibration plan can help you weigh confidently. What is calibration? Let's imagine you're a soup producer. When you add salt in your soup production, you know adding 1% more or less of the required amount is still okay without being too salty or too bland. But are you sure to have added salt within plus or minus 1%? Like all measurement devices, balances and scales have an inherent uncertainty, which can compromise your plus or minus 1% tolerance range. This is where calibration comes in. It quantifies how accurate your weighing results really are by determining the performance of your balance or scale in its actual place of use. For this, Mettler Toledo offers you the Accuracy Calibration Certificate so that you can find out how accurate your balance or scale.
Okay. So mana siya no ang kaning digital weighing scale or even kaning sa timbangan ng bayan, na sila yung method of calibration. So, na sila yung mga test weight, no? Pag magdaladala ang kuana na, I don't know, DTI may magdaladala. Pag timbang ngayon nila, pagbutang ngayon nila silang test weight, no? Standard test weight sa inyo ang weighing scale, regardless kung mechanical or analog, mechanical or digital, maghili ngayon na siya mula, pag mulapas, ngayon na siya, impas ka. No? Now, the same is true with this one. No? Some companies, or most of the companies, are practicing gitawag nila na third party or outsourcing the calibration for their instruments, particularly this digital weighing scale. So magpatawag na sila, so magbayad, magasto na sila sa mga calibrator, maadto ang calibrator sa on-site, then gina-calibrate nila ang then issuehan din sila og certificate. By the way, the Mettler Toledo is one of the most expensive digital weighing scale na ako ang nabala na naka-encounter. So, pa ni sila. Sikat pa ni siya na brand, even for metal detectors and so on and so forth. Okay? So, na may pangutana. So, dapat, naagi kay dapat, yan yung certificate. Now, there are some company as well na magpa-train sila, no? And they have this license or certificate na sila calibrator. So, pwede po na they can perform their own calibration, no? Provided that one of their methodology is ang katong ilahang standard test weight, no? Katong standard na test weight na ipatong nila sa ilang timbangan is calibrated. I don't know, murag annually man siguro gina-calibrate ang katong standard na test weight. So the same is true sa ato ang school, no? The physics or chemistry department, ipadala na nila either sa DST man siguro for standard na testing. Magduga ka na sila mga bulitas sa sulod sa test weight, no, para ma-improve increase or decrease ang weight sa ilang standard na test weight. So since ang uban ga calibrate man, so allow me to to show a video on unsa ang calibration procedure for any no digital weighing scale.
Welcome to Precision Weighing Balances. Today we'd like to go over the calibration of a Sartorius AY series. The manual explains how to do the calibration on page 16 of the manual, so I have the manual here. We still get a lot of phone calls from people asking for assistance. How do I exactly calibrate the balance? So we decided to make this video to give you an example. The demonstration that we're going to be showing today, this is an AY412. So on the Sartorius AY series, the AYs 123, 303, 212, 412, 612, 511, and 711 all come with the calibration weights. So a lot of phone calls we get are, where are the calibration weights? So in the rear of the scale, on the right-hand side, you can open up the little compartment, and you'll see on this particular scale it comes with two 100-gram weights. So we'll be calibrating the balance with these two 100-gram weights. Now, the only balances that have the sprint level, your balance should be level when you do your calibration. The only balance in the AY series that come with adjustable feet in a sprint bubble is the AY 123 and 303. So I'm just going to move this scale aside for a minute and show you the model AY. This is an AY 303. You can tell it has a smaller weighing pan, and it has this little glass draft shield. But what I wanted to show you is, number one, you'll notice there's a sprint bubble right in the center of the scale for leveling the balance. And also on the AY 123 and 303, there are 4 adjustable feet. So we get a lot of phone calls from people. Again, we always say we get a lot of phone calls. A lot of people call us with 1,000 questions. And basically, if you look at the bottom of this AY41, this is the AY412, you'll notice there are no adjustable feet. The only balances, again, that come with the adjustable feet are the model AY123 and AY303. So your balance should be level prior to doing your calibration. So let's go over how to calibrate the balance. And another reason for calibrating a balance is everywhere in the world is a different magnetic north. So balances should be calibrated, and the manual says let's calibrate the balance before putting it into service. So as I mentioned, the balance should be level, which it is, and you want to turn on the balance, and you'll notice in the left-hand corner there are these, it looks like a weight. There are two, it's a balance beam with 2 weights hanging. This is your stability. So your balance, before doing the calibration, should show that the balance is stable. So what you want to do to perform the calibration is first, hit the 0 key. The 0 key will make sure that the balance is to 0, 0. And to start the calibration, you want to press the cal button. The cal button shows 200 grams. Now this is the default. If you wanted to, you could change the calibration by repeatedly pressing the F key. So if I press it once, you'll notice now we can calibrate it with a 200 gram weight. If I press it again, we could do it with a 50 gram weight. And if I press it again, we'll go back to 200. So we'll leave it at 200, the factory default. And now what you want to do is you want to hit the enter key. So the balance says cal, and it starts to flash 200. And what we want to do is we want to put our 200 gram weight, and we're going to put it right in the center of the balance. And you'll notice the balance flashing, and all of a sudden it reads 200, and it's steady. So the balance has now been calibrated, and if we remove the weights, you'll see the balance goes back to 0.
Okay, so guys, so ang mga digital weighing scale na sila self-calibration na mga functionalities, mabasa rin siya sa manual. So I'm just showing you kay mo man ni mas dali ra makita sa YouTube. Okay. So napay katong type na platform, no? Kaning platform type na kuan na weighing scale manay ganing common sa kanang mga sinako na mga product, no, especially if bagging, no, nakaibaging sa imong product then ginatimbang diretso sa imong platform weighing scale. Allow me to demonstrate lang how complicated to self calibrate the inani na type na kuan na platform type na weighing scale. Okay guys, so I hope na nakita ninyo, though the audio is not really that important. I'm just showing to you na tagaan kay pislit-pislito, no, especially pag inani platform type na ganing weighing scale, unlike ato ganiya, no, ang laboratory ra to siya na type na weighing scale, mas simple siya pag inani mas lisod, no. So in some production na procedure, hourly sila ga-check, no, timbang nila, butang nila ning test weight, no, dapat standard na test weight. Pag butang nila, pag within the tolerance sa ilahang sa ilahang accuracy, no, na gi-require, so padayon na po na sila. Padayon na pa sila gamit sa timbangan. So, na uban hourly, ang uban 3 hours. Every 3 hours. Pero pag timbang nila out of range na ganyan sa ilang accepted na accuracy or tolerance, anong tawag din sila og kuan, engineering, pa-pull out of unit or pwede siya ipa-check. Yes, Kent, nakay pangutana Kent. Kent? Wala din siya pangutana. Okay, so inana ang kuan. So matingala mo ano appeal man sa at appeal man sa tuwa ang kuan at appeal sa tuwa ang instrument ang kaning timbangan. Yes, no appeal ni kay not all production are doing automated na weighing sa ilang product. Most of the production are doing manual. Kinasa ka makaadto, I could say mga 90% siguro there is sa Mindanao is doing manual na weighing of the products. So, and they're using digital weighing scale. So, it's very important that even though pandemic na karon, you have an idea, no, na inana there, no, there's a certain procedure na pwede nimo ipangutana, no. So, pwede nimo ipangutana sa imong kauban, especially if you belong to the engineering team, no. So, stop. Dili na pwede kay i-continue share.
Ang bawat tasa mo ng Nescafe, tulong sa pagbangon.
Okay, so in this video, makita ninyo ang platform na type na digital weighing scale. Yun sa niya pagtaot or replace load cell. Okay? So, dili sa English, no? Wala ako kayo.
तो ये प्लेटफॉर्म हमारे सामने आ जाएगा इसके अंदर ये
Tanawan na
सारे
lang
लोड
ninyo
सेल
ang
नहीं लगा हुआ
procedure.
इसके अंदर तो सबसे पहले हमें लोड सेल लगाना है नीचे वाली प्लेट के अंदर लोड सेल रखने के बाद चारों एल की बोल्ट इसके अंदर लगा देना है और इन चारों एल की बोल्ट को हमने टाइट कर देना है ये देखें दोस्तों चारों एल की बोल्ट लग चुके हैं उसके बाद हमने चारों एल की बोल्ट को एलन की के ज़रिए टाइट कर लेना है उसके बाद हमने ऊपर वाली प्लेट को रखना है ऊपर वाली प्लेट को रखने के बाद हमने चारों एल की बोल्ट को लोड सेल के साथ टाइट कर देने हैं उसके अलावा मैं आप लोगों को ये भी कहता चलूँ कि अगर आप लोगों ने किसी तरह का भी प्लेटफॉर्म लोड सेल या इंडिकेटर आपने ख़रीदना है तो आप हमारे व्हाट्सएप पे रब्ता कर सकते हैं तो आपको बिल्कुल मुनासिब रेट पे आपको ये मिल जाएगा एल की बोर्ड थोड़े से टाइट करने के बाद हमने प्लेटफॉर्म का लेवल पहले चेक करना है उसके बाद एलन की के जरिए हमने एल की बोर्ड को अच्छी तरीके से टाइट कर देना है उसके बाद हमने
Okay, so kita niyo, no, dapat the platform is balanced, no? Though the load cell is at the center, so naman siya kanang ganing structure niya na maskin sa kilid na nimo timbangon, maigo gyapon niya ang load cell sa center. So that's why gina-check siya kung ang platform niya, no, including the structure, kay kuan perfectly kuan gid siya horizontally naka-horizontal yun, no, walay nakaangat. Okay, so mao na ang sa kaning kuan sa digital na platform na weighing scale. How to replace load cell, how to check siguro load cell. Then this will be our last na video before to mahuman. kaning kuan, kaning asa man to. Napaday isa, ano? Napaday isa.
Truck scales need to be checked, tested, and adjusted on a regular basis. It may be necessary to trim the load cell outputs as a first step before starting the calibration process. Trimming is performed at the junction box to equalize the weight reading from all load cells in the truck scale system. This ensures that the scale weighs correctly regardless of where the load is applied to the scale. Load cell trimming and calibration should always be performed by state-certified and factory-trained scale technicians. There are also multiple systems on the market to trim and calibrate a truck scale through a digital interface. Discuss each manufacturer's calibration system with your scale supplier to determine the best system for your application. Every vehicle scale should be calibrated and tested frequently to ensure proper performance. Accurate truck scale calibration is vitally important to any operation, especially applications requiring legal for trade use. A truck scale should be calibrated and tested by a state-licensed service agency using no less than 12.5% of the scale's nominal capacity of certified test weights. The scale's calibration interval is determined by the frequency of use, individual application requirements, and federal, state and local guidelines.
Okay guys, so napay gitawag na dinagko na scale no ng weigh bridge. So kung kabantay mo ng mga sa DNR, ang tawagan na mga track scale. Track yun ang ginatimbang. So I'm just showing you na there is that scale na pinakadako. Particularly kanang require sila og kanang loading sa mga lubi, or loading sa kanang sa DNR, loading sa mga logs. So naapat kay video sa pangitaan. Kundo siya. Sorry guys, nawala man ang video, galaw ga. But anyway, review na lang to ninyong nasa example na conveyor type na kuan na weighing scale, no? Nato siya nato na nawala lagi akong kapangitaon din, nawala man. But then again, kuan naman ganing almost 2 hours naman ta, so we're going to stop na. Okay, na may pangutana. Okay, so kung wala na may pangutana, recorded man niya, I'm going to post the recorded video para kuan niya tanan. Ang attendance, atong kuan, kung wala pa naka-attendance, akong i-paste ang attendance. Okay, so bye na ta. Bye-bye.
Thank you, sir.
Thank you,
sir.
Thank you, sir.
Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Ay, goodness.
Inay pangutana si Ronel. Nag-raise lagi siyang hands. Ronel, naka diya? Nakay pangutana? Ito to nag-raise silang hands.
Thank you, sir.